mahafarka.co.in. In today's article, we are going to deal with Pascal's law. In a previous article, we have learned the basic formula to find the pressure, and that formula was pressure is equals to force upon area. Okay. Sir Pascal studied the pressure applied to the fluid at rest, to the different fluids at rest, and he observed one important thing, and that we are going to call as what? Pascal's law. Pascal's law is one of the most important thing that we are using in our day by day routine also. For example, when you go to the doctor, when doctor advised you to take injection for any particular disease, then the injection which is given by him is basically working on the Pascal's law. The syringe has a piston, and that piston works on the Pascal's law. When you are driving heavy vehicles like trucks or motors or cars, we have hydraulic brakes. That hydraulic brakes has an air tank. So it again uses the concept of pressure. So what is that Pascal's law? To understand that, imagine that I am having one container in which fluid is placed, fluid is filled, and that fluid is at rest. That fluid is at what? Rest. Means no movement of the fluid inside the container is there. Like that we have considered here. Now I had one piston, and I can apply the force to the piston so that it can go down. In that case, when I applied the force, before that, suppose there are some points where I had made some holes to the container, and to these holes I have connected barometer or the instrument which is used to measure the pressure. And so that 1, 2, 3, 4, 5 different barometers are connected there. May or may not be the holes are of same areas. May or may not be. They may be of same areas or they may not be. Now what I have done is I had applied force using this piston, so that this force acts on the area of the piston, so it exerts the pressure. It exerts what? Pressure. This pressure is acts on the fluid which was at what? Rest. Now this pressure, according to Pascal, that pressure has to transmit in the different walls of the different parts of the wall of that container. So it is transmitted in these different parts like P1, P2, P3, P4, P5. Okay. So what Pascal has observed that these values of barometer readings, mercury, whatever the readings are there, the values of pressure read by this barometer P1, P2, P3, P4 and P5 were similar. Means here the pressure P1 is equals to P2 equal to P3 equal to so on. But what is formula for pressure? So it is force upon area for first case is equals to force upon area for second case is equals to force upon area for third case. Or I can write this statement: forces at these 2 points, ratio of force at these 2 points is equals to ratio of areas at that 2 points also. So this is the Pascal's law. So if I want to state this Pascal's law in a very simple words, what we have done is we have applied the pressure to whom? The fluid which was at what? Rest. So pressure applied to the fluid which was at rest is transmitted in all parts of the fluid. It is transmitted in what? All parts of the fluid. This fluid is transmitted in all parts, but while transmitting it is transmitted equally undiminished. Undiminished means what? Total pressure of all these is equals to the applied pressure. Okay, so the same pressure is transmitted through all the part. So if this is pressure P, then here also P, here also P, here also P, and here also, like that we can say. So if I want to state the statement of Pascal's law, so I can say pressure applied to the fluid at rest, any part of fluid at rest is transmitted equally to the all parts of fluid without diminished or undiminished. Now to the all parts of fluid at the walls of fluids also, walls of container also, or walls of vessel also. Okay, so this is the Pascal's law. So what we can say here, pressure applied to the any part of fluid which is at rest is transmitted equally to the all parts of fluid plus wall of container, and it is undiminished. So no decrease in the magnitude of pressure is takes place, and this statement is called as what? Pascal's law. In the Because of this invention, we have given the unit of pressure in the name owner of Sir Pascal as Pascal. Therefore, we used to write 1 Newton per meter square is equals to what? Pascal. Okay. We are going to learn the application of Pascal's law. One important application is hydraulic press, or the same principle can be used to study hydraulic lift also. So let's start it. What is there? First thing that we need to go through is the construction. So as you can see, it is a water tank. There is a water tank with two openings. One opening has small piston fixed to it of area of cross section A1. So A1 is the area of cross section of that piston. I will call it input piston. We will call it as what? Input piston. Now, another metal plate. Suppose I want to use it as a press to crush oil seeds, to crush cotton bales. I can use this press. So suppose I want to keep this object on another metal plate whose area is A2. So A1 is the area of input piston, whereas A2 is area of output piston. Okay, on which you are going to fix the object. Suppose one very hard metal plate is fixed here to the wall or to the terrace. Then if this moves with large force in upward direction, object in this will get crushed. Okay, so that we can use it as what? Hydraulic press. So how it is going to work? Say I had applied force F1 on the input piston. So force applied on input piston. Force applied on the input piston. Now this force acting on this area will exert the pressure. Say P1 is the pressure at input piston. P1 is the pressure at what? Input piston. Now this pressure will transmit to the wall of vessel, wall of tank, and to the every part of the fluid like this. So it is going to travel in this direction. That pressure applied to the fluid which was at rest now, according to Pascal's law, it is going to transmit. So now P2 will be the pressure acting at output piston. Say P2 is the pressure acting at the output piston. But what Pascal said, that pressure is what? Transmitted equally. So I can say by Pascal's law, we can say P1 is equals to what? P2. According to formula, what is P1? Force upon area. Okay, equal to force upon area. So input piston has pressure force F1 upon area A1. Output piston has pressure P2 equal to F2 upon A2. F2 is the expected force that is going to act here. Now what we just need to prove here, that F2 is greater than F1. Now from this equation 1, F2 can be equal to A2 into A1 upon F1 upon A1. We have seen that A1 and A2, here A2 is greater than A1. So I can say since A2 greater than A1, if A2 is greater than A1, so this value F1 upon A1 into A2, but A2 is greater than A1, so this value will be more than 1. So if it is more than 1 means F2 will be more than 1. If it is unity, then here I can say, therefore F2 will be greater than what? F1. Now using this I can say that though you have applied smaller force, to the input piston, the pressure is created here, that pressure is transmitted equally, and that pressure, same pressure, exert very larger force on this particular plate or particular output piston, so that it moves with certain force in the object inside that get pressed. Okay, so this is the working of what? Hydraulic press. If I want to lift heavy object, then I can do the same, so it can be hydraulic lift also. Another applications of Pascal's law are like hydraulic brakes. Okay, this is hydraulic brakes, hydraulic press and hydraulic lift are working on the same principle. In hydraulic brakes also, when driver applies the force to the brake pedal, the same force, the force is transmitted to the air tank, piston in the air tank exert pressure, and then it exerts on the drum which is connected to the wheel. If suppose this is the wheel, then that wheel is connected to two small tanks with rubber plates. So here it is initially air is filled, means fluid is there suppose, and when force is added, that rubber pads moves in a forward direction with larger force, and because of that larger force this wheel stops instantaneously. So these are the applications of Pascal's law. I hope you understood this. Have a good day. Thanks for watching mahasarkar.co.in. Thank you again.